All right, guys, we're going to continue factoring special cases and factoring by grouping. We're going to go through a couple of these together, and then you will go ahead and do the rest on your own. And so we're going to start with number 2, and the first thing that I want you guys to recognize is that 16 and 9 are perfect squares. And so if we break that apart, we have 4 times 4. And if we break 9 apart, we have 3 times 3. And so if we go ahead and actually factor that and split it into our double parentheses, we're going to have 4k times 4k. And then we're going to go ahead and switch gears and we're going to look at our 9. And we're going to have 3 and 3. Well, we know that because all signs are positive here, everything is going to be positive here. Okay? And I'm going to go ahead and just distribute this so you guys see that we get back to our original problem that we needed to factor. Okay? And so we have 4k times 4k, which gives us 16k squared. We have 4k times 3, which gives us 12k. We have 3 times 4k, which gives us 12k again. And 3 times 3 gives us 9. And so we have 16k squared plus 24k plus 9. And so that is exactly what we started with. And so you guys don't need to do this, so I'm going to cross that off. My main focus is this. And we can actually write that in a simpler way. But I'm okay with you writing it how it is written. But if you guys want to write it simpler, you can write it like this. Because that just means that we multiply this by itself, okay? And so let's go ahead and move on. We're going to look at number 3. And so we're going to approach it the same way, right? We are going to see, okay, do I have a perfect square? Do I have multiple perfect squares? Well, I have 1a squared, so I know that I'm going to be able to break that apart. And I'm going to be able to say, well, I have a and a. And then I'm going to have 1 and 1. And so I have 1 and 1. And my signs are going to be negative for both because I have a negative in the middle and a positive on the outside. And so if I rewrite this, I can write it as this, and it is the same exact thing as saying the quantity of a minus 1 times the quantity of a minus 1. So let's go ahead and continue on. And so again, with 6, we're doing the same thing. So we recognize that 25 is a perfect square. And so we have 5x and 5x. And then if we look at 4, we know 4 is also a perfect square. And it's 2 times 2. And so we have 2 and 2. Just like number 3, we have a negative in the middle and a positive on the outside. And so both of our signs are going to be negative because if we multiply 2 by 2, well, we get a positive 4. But then if we subtract, right, negative 2 minus 2, or when I actually multiply it out, it'd be negative 10 minus 10, we get a negative 20x. So this would be our answer, or it can be written as 5x minus 2 squared. Okay. And so I'm going to go ahead and let you guys finish 7 and 8. I'll go ahead and start 7 for you. And so we know that 1 is a perfect square. If we break it apart, we have 1 times 1. We know that 16 is a perfect square. We break it apart, it's 4 times 4. And so you're going to set up your double parentheses, and then you're going to fill those in, okay? So let's look at 10. So again, we're going to go through it real quick, right? If we break 4 and 4 up, we know it's 2 times 2. It is a perfect square. So we have 2r and 2r. The difference with this one is that it is a difference of squares. We don't have, we don't have that middle r term, right? And so we know that my signs have to be different in order to make sure that we don't have that middle R term. And so we can't actually simplify writing this one because of the different signs. So it would stay the quantity of 2R plus 1 times the quantity of 2R plus 1. Okay? So now let's look at factoring by grouping. And so the first thing that I want you guys to always do is group the terms. Okay, so we have one group and we have another group. Okay, let's go ahead and do this for 14 as well. So we have our groups. Okay, I'm going to do it for 15. We have our group. We have our second group. Okay. So recognize that we are grouping and we want to get, two binomials. And so if I'm looking at this, I'm looking at 5n cubed minus 8n squared. Well, what is my greatest common factor that I can take out of just this piece here? Well, I recognize that I can take an n squared and I will have a 5n minus 8 left over, right? If I take an n squared from 5n cubed, well, 3 minus 2 is 1, so I have 5n, and that's how I get this term here. And then I do the same thing with my negative 8n squared, okay? And so now we're going to look at this group here, and I'm going to switch colors so we see it. Well, I have 20n and I have 32. What is the greatest number I can take out of those? Well, I can't take 20. So I'm going to look for 5. I can't take 5, but I can take a 4. So I have plus 4. And if I divide 20n by 4, I'm left with 5n. And 32 divided by 4 is 8. So 5n minus 8. If you guys recognize something, these pieces are the same, which is exactly what we want. If these two pieces are not the same, it means that we did something wrong. Okay, if they are the same, then we did something right. And so if I rewrite this, I have n squared and 4, these terms go together, times 5n minus 8. And this would be my final answer. Okay, seems a little tricky. We're going to continue to go over this. So let's move on to 14. And we're going to look at the first group. And I can't take a number out because 2 doesn't go into 7, and nothing that goes into 7 can be divided by 2. But I can take a k squared out. And so if I take a k squared, I have 2k minus 7 left. Well, if I go ahead and switch and go to my second group, what can I take from 8 and 28? I can take a 4, okay? So I have plus 4 times 2k minus 7. Well, do we have the same terms in our parentheses? We do, so we know that we did it right. So if I rewrite this, I have 2k minus 7. And then in my first set of parentheses, I have k squared, because my k squared and my positive 4 go together to complete the factored form of this polynomial. Okay? So we're going to take a look at one more, and then I'm going to let you guys go ahead and do some. And so if I'm looking at my first group, I have 5n cubed plus 35n squared. Well, I recognize right off the bat that I can take a 5, and then I see I can take an n squared, and so I'm left with n plus 7. And I'm going to look at my second group, and I see that I can take a 3, so I have plus 3 times n plus 7, because if I take a 3 from each of these, I'm left with n plus 7. Well, both of my terms here, my binomials are the same, so I did something right. And so my final answer would be 5n squared plus 3 times n plus 7. Okay, let's go ahead and do one more. I'll make it quick. And so I have my first group here, my second group here. So I have 12n cubed plus 6n squared. Well, I can take a 6n squared and I'm left with 2n plus 1. And I can take a 5 from my second group, so I have plus 5, 2n plus 1. Well, both of these binomials are the same, so it means that we did it correctly. So I have 6n squared plus 5 times 2n plus 1. And that would be my final answer. I cannot factor it anymore. Okay, so again, you guys have a couple problems for homework, but bring any questions that you have.